Section 2.5, solving absolute value equations and inequalities. Absolute value contains the straight bars on each side of your term. This case is absolute value of 2. Absolute value means the distance from 0 on a number line. So absolute value of 2 would be from 0 to the 2. The absolute value of negative 2 is the distance down 2 units the other side of 0. Now, we do not count distance in negative terms, so this is 2 units from 0, which means absolute value of negative 2 equals 2. As well as the absolute value of positive 2, it also equals 2. So absolute value is the value without regard to its sign. And the absolute value of a number can never equal a negative value. Cannot equal a negative value. Now, the number underneath there can be negative, but the absolute value cannot be equal to a negative value. For example, 5 times the absolute value of x minus 4 equals 1. We solve it in the same way as if there were no absolute value sign at all. So first we're going to add 4 to both sides of the equal sign, and we have 5 times the absolute value of x equals 5. Then we're going to divide both sides by 5, and we get the absolute value of x equals 1. So therefore, x itself is either negative 1 or positive 1, because the absolute value of negative 1 equals 1, and the absolute value of positive 1 equals 1. So solution, x equals negative 1 and positive 1. When you have more than one term inside your absolute value brackets, we need to create 2 separate problems without the absolute value brackets. We start with 2y plus 5 equals 9, exactly like our original problem. And then we make another one, 2y plus 5 equals negative 9. For the second problem, change the sign of this term out here. Always. Now we're going to solve both of these. So subtract 5, 2y equals 4, divide by 2, y equals 2. On the other one, subtract 5, 2y equals negative 14, divide by 2, y equals negative 7. So we have 2 answers, y equals 2 or y equals negative 7. If I plug those back in to our original inequality, I will see that they both work. If y is 2, that will give me 4 plus 5, which is 9. Absolute value of 9 is 9. That is true. On the other one, 2 times negative 7 plus 5 equals 9. 2 times negative 7 is negative 14 plus 5 equals 9. And the absolute value of negative 9 is 9. Again, true. Therefore, both solutions work, and we have 2 answers. Y equals negative 2 or y equals negative 7. I'm sorry, y equals positive 2 or y equals negative 7. Solve an absolute value inequality. Remember, we make our 2 equation or inequalities, one exactly as is and the other with the negative sign? Well, when we put the negative sign, we also turn our inequality the other direction. And to make this easier, rather than doing this in two separate problems, we can do it in one. Notice that they both problems contain x minus 3. So let's put the x minus 3 in the middle. And then put in the less than or equal to 4 and the greater than or equal to negative 4. Notice I switched that around here because it's pointing towards the negative 4 right here. It must be pointing towards the negative 4 right there as well. So I didn't flip the sign, I just rotated because I rotated the problem. So now we are going to solve for x all at one time, which means I'm going to add 3 to every single side of an inequality, to all 3 parts. In the middle, they cancel out, giving me negative 4 plus 3 is negative 1, and 4 plus 3 is 7. So I now have negative 1 is less than or equal to x, and at the same time, x is less than or equal to 7. So I find my negative 1, x is less than that, so I'm going to use my square bracket because of the equal sign, and I'm going to shade. Then I'm going to find my 7. Actually, I put that the wrong way. Negative 1 is less than or equal to x, meaning x is greater than negative 1 or equal to. I put it the wrong way. Now I find the 7 and x is less than or equal to the 7, and then I shade in between the 2 brackets.